Principles of heat transfer. Housing. First is conduction. Conduction is heat traveling through a solid materials, such as on hot days, heat is conducted into your home through the roof, walls and windows. Heat reflecting roof, insulation and energy efficient windows will help to reduce that heat conducted. The second one is about radiation. Radiation is about heat traveling in the form of visible and non-visible. Sunlight is an obvious source of heat for homes. In addition, low wavelength, non-visible infrared radiation can carry heat directly from warm objects to cooler objects. Infrared radiation is why you can feel the heat of a hot burner element on a stove top from across the room. Older windows will allow infrared radiation coming from warm objects outside to radiate into your home. Shades can help to block this radiation. Newer windows have low E coatings that block infrared radiation. Infrared radiation will also carry the heat of your walls and ceiling directly to your body. Now I want to talk about convection. For convection part convection is the heat from your walls and ceiling to reach you. Hot air naturally rises, carrying heat away from your walls and now we go to the part of cooling your body. The first one is about convection. Convection is when heat is carried away from your body via moving air. If the surrounding air is cooler than your skin, which means the air will absorb your heat and rise. As the warm air rises around you, cooler air moves to take its place and absorb more of your warmth. The faster this convecting air moves, the cooler you feel. Okay, that is for convection part, and now we go to the radiation. Radiation is when heat radiates across the space between you and the objects in your home. If objects are warmer than you are, heat will travel towards you. Removing heat through ventilation reduces the temperature of the ceiling, walls and furnishings, which means the cooler your surroundings, the more you will radiate heat to the objects rather than the other way around. Furthermore, perspiration can be uncomfortable and many people would prefer to stay cool without it. However, during hot weather and physical exercise, perspiration is the body's powerful cooling mechanism. As moisture leaves your skin pores, it carries a lot of heat with it, cooling your body. If a breeze or ventilation passes over your skin, it will moisture and will evaporate more quickly, and you will be even cooler. Heat transfer in buildings. Heat transfer is the process of thermal exchange between different systems. Generally, the net heat transfer between two systems will be from the hotter system to the cooler system. Very broadly, the mechanism of heat transfer can be described as conduction, convection, radiation, and phase change. Conduction is the diffusion of internal heat within a body as a result of temperature difference across it. Okay, this is particularly important in buildings where there may be a temperature difference between the inside and outside of a building, such as in a heated building during winter. Conduction is one of the main potential heat transfer mechanisms by which the internal heating or cooling can be lost to the outside. This can be resulting in high operating costs, high carbon emissions, and occupant discomfort. For building materials, it is sometimes thought that conductivity is expressed by the U value. However, U values are the reciprocal of the sum of the thermal resistance of a body plus its inside and outside surface thermal resistance. Conductivity is more accurately expressed by a material's R value, which is the reciprocal of its thermal resistance and does not include a surface component. You can browse for UVA for more information about this. Okay, next is conduction can be inhibited by insulating materials which have a high thermal resistance and so help reduce heat transfer between the inside and outside. An insulating effect can also be achieved by the thermal mass of building components. Thermal mass describes the ability of a material to absorb, store, and release heat energy. Thermal mass can be used to even out variations in internal and external conditions, absorbing heat as temperatures rise and releasing it as they fall. In building design, this can be useful for evening out and delaying extremes in thermal conditions, stabilizing the internal environment and so reducing the demand for building services systems. Now we go to the part of convection. Convection is the movement of a fluid such as the air by advection and diffusion. This is a very important mechanism in the design of buildings where air movement is necessary to moderate internal temperatures, reduce the accumulation of moisture, odors, and other gases that can build up during occupied periods, and last but not least is improve the comfort of occupants. Convection is also a heat transfer mechanism resulting from the movement of air of different temperatures. Air movement in buildings can be forced, for example driven by fans, or natural, resulting from pressure difference from one part of a building to another. Natural air movement can be either wind-driven or buoyancy-driven. Accurately predicting the movement of air within buildings is extremely complicated and can require the use of computational fluids dynamics (CFD) modeling software. NB fluids can also be used to transfer heat within a building by mass transfer, for example by the flow of a refrigerant, chilled water or hot water around a building to provide heating or cooling. Radiation. All bodies which are hotter than 0 degree Kelvin emit thermal radiation. They also absorb thermal radiation emitted by their surroundings. The difference in the total amount of radiation emitted and absorbed by a body at any given moment may result in a net heat transfer, which will produce a change in the temperature of that body. The range of terrestrial temperatures experienced within the built environment is relatively small, and relative to the temperature of the sun, This range is cool and so radiating at a long wavelength compared to the sun. This anomaly allows us to categorize thermal radiation as short-wave solar radiation and terrestrial or long-wave infrared radiation. Surfaces in the built environment will tend to absorb solar radiation and emit long-wave infrared radiation. This difference also produces effects such as the greenhouse effect. The atmosphere is relatively transparent to solar radiation, which this means it allows sunlight to enter the atmosphere and heat the Earth's surface. These surfaces then re-radiate that heat as long-wave infrared radiation, which greenhouse gases tend to absorb rather than transmit. The result is that the long-wave infrared radiation is trapped and heat accumulates in the atmosphere, causing a warming process. The thermal properties of a material are a function of three basic parameters: transmittance, reflectance, and absorptance, or emissivity, describing the ratio of the transmitted, radiated, or absorbed radiation to the incident radiation. These properties vary depending on the wavelength and angle of the incident radiation. Last but not least is phase change. Phase change is when substances change phase. For example, changing from liquid to gas. They absorb or release heat energy. And for another example is when water evaporates, it absorbs heat, producing a cooling effect, and when it condenses, it releases heat. So when water evaporates from the surface of a building, or when sweat evaporates from the skin, it has a cooling effect on it. This is also important in refrigeration, which means phase change is important in refrigeration, where refrigerant gases absorb heat from the cooling medium, typically water, as they evaporate, and when they condense, they are releasing heat, which is rejected to the outside. Phase change materials can also be used in construction. This is to reduce internal temperature changes by storing latent heat in the solid, liquid, or liquid gas phase change of a material.